Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, today we'll take question number 15 of JEE Mains Physics paper 2017. So let us solve the question number 15 Physics paper JEE 2017. So let's start students with question number 15. The question says there is a capacitance of 2 microfarad is required in a electrical circuit. So the total capacitance you require is 2 microfarad. Now what is the availability? Across a potential difference of 1.0 kilovolt. This is 1 kilovolt. So we have to connect across the available potential difference of 1 kilovolt, and we have to have a capacitance of 2 microfarad. Now how will you arrange that? The given thing is that a large number of 1 microfarad capacitors, large number of 1 microfarad capacitors are available to you. You take as many as you want, arrange them so that you get 2 microfarad capacitor in the circuit, and which can withstand the 1 microfarad capacitor each can withstand a maximum with potential difference of not more than 300 volt. That means each capacitor can be given a potential difference of not more than 300 volt. That means if it is 300 volt then it's okay, but not more than 300 volt. The minimum number of capacitors required to achieve this is. The question is that if I have a capacitor, only capacitors available are 1 microfarad, these are available, and the potential difference should not be more than 300 volt. So I have to keep these two in mind, that if I increase the potential by more than 300 volt, it will break down. So this is, you can call this as the breakdown voltage of 1 microfarad capacitor. If this is a breakdown voltage, then I have to connect this in such a fashion that the potential difference in none of the capacitors will be exceeding 300 volt. Now, and what is available is I have to connect across a potential difference of 1000 volt. Now, how many such 1 microfarad capacitors I will take, in whatever way I have to arrange, that we'll discuss. Now, 1 microfarad capacitor, if I take 1 microfarad capacitor and connect this, then this will get a potential difference of 1000 volt, which will burn the capacitor. If I take 2, 1 and 2, 1 microfarad capacitor in series with another microfarad capacitor, then that 1000 volt, again I connect this to 1 kilovolt input, because that is the available potential difference. Then each capacitor will get 500 volt and 500 volt, because in series the potential is divided, and because the capacitance is same, it will be equally divided. So therefore each one will get 500 and 500, which is more than 300 volt, then also it will break. If I connect 3, then this 1000 volt will be divided something like 1000 by 3, 1000 by 3, 1000 by 3, or it will be something like more than 333. Then again it will break. So my choice is that I will take 4 capacitors. If of 1 microfarad each in series, then each one will get potential difference of 250 volt. 250, 250, 250 and 250, all these 4 will come together to give you 1000 volt. This is how you distribute the potential difference in series of those capacitors. So if that is the case, then in one row I'll connect 4 capacitors. In one row I'll connect 4 capacitors each of 1 microfarad, and they'll consume a potential difference of 250 volt. That is fine. Now next thing is, our aim is to protect the capacitors as well as to have the desired result, that is desired our desire is to have a capacitance of 2 microfarad. We have to have a circuit which will give the net capacitance of 2 microfarad. To have net capacitance of 2 microfarad, these 4 capacitors which are connected in series, we will get the total or equivalent capacitance of 1 by 1 plus 1 by 1 plus 1 by 1. In series combinations, you know, you have to use the parallel formula for resistances. 1 upon C equivalent is 1 upon 1 upon, so that is 4. So C equivalent will be 1 upon 4. So therefore the C equivalent will be 1 by 4. So if I connect 4 capacitors, I'll get 1 by 4. But my aim is to get 2 microfarad capacitor. To get 2 microfarad capacitor, how many such rows or series of capacitors to be connected in parallel? Because in parallel the capacitance will increase. In series combination of capacitors, the effective capacitance will decrease. Our aim is to move to 2 microfarad, to achieve 2 microfarad, and in series we have got a bunch of 4 capacitors, each of 1 microfarad, and total combination gives you 1 by 4 microfarad. So our journey is to move from 1 by 4 microfarad to 2 microfarad, and that can be achieved by connecting those rows like such rows in parallel. So if I take 2 rows, 1 by 4 microfarad, then I take another row containing the same 4 capacitance series, then that will also give me 1 by 4. So this 1 by 4 in and this 1 by 4, these two are in row parallel, so that will give me 1 by 4 plus 1 by 4, so that will give me 1 by 2. So similarly, how many such I will take? Suppose I take x number of those rows in parallel connections. In each row I have 4 resistors, 4 capacitors. Then I will take suppose x number of rows. So that x number of rows, that x into 1 upon 4 should be equal to 2. So therefore, x number of rows, x into 1 by 4 should be equal to 2. So x should be equal to 8. If x is 8, that means the number of rows I required is 8. If number of rows is 8 and each row, that is 4 capacitors, so 8 4s are 32, that is the answer. So this should be the answer. Then how to find that? Let us proceed. If I have 1 capacitor, I connect this to 1000 volt, 1 microfarad, then this will burn. This is not going to work. If I connect 2 capacitors, because the available capacitors are 1 microfarad each, so I have to connect only 1 microfarad. If I connect this and connect with the 1000 volt battery that is given in the question, then this will have 500 volt and this will have also 500 volt. This will have 1000 volt. Our aim is to get less than 300 volt. So this will burn, this will also burn. This will also burn. Now, if it is burning, then I have to, if I suppose take 3 capacitors of 1 microfarad each and connect it to 1000 volt input, so equally the potential will get divided because they are in series. So here it will be something 333 point, some nearly 33 volt, here also 33 volt, here also 333 volt, which is more than that. That is also burn. This will also burn. Then we have to see for more connections. So if I go for combination of 4 such 1 microfarad capacitance, 1 microfarad capacitor in series and connect that with 1000 volt, then equally the drop will be equal. The potential drop here will be 250, 250, 250, 250. That is fine, because that number 250 is less than 300. That is okay, because the capacitor will be protected, and that is the thing. So minimum we have to consider 4 capacitors in series. But if I do so only for my capacitors are protected, but the total capacitance I'm getting out of one such combinations of one row, that is because they are in series, so the equivalent capacitance of this combination will be 1 by 4, because the formula, you know, 1 upon C equals to 1 upon C1 C2, like that. So it is 1 upon 4. That is the value I'm getting. What is the question? The question, it was given 2 microfarad, but I'm getting 1/4 of microfarad. So if I know that if I connect capacitors in parallel, that value increases. I connect one row, suppose I connect 2 rows, then I have a situation like this, and one more row connected exactly like this over here in parallel, then my capacitance will become double of this. So it will become 1 by 4 plus 1 by 4, that is 2 by 4, that is 1/2 microfarad. But that is not enough. I have to increase to 2 microfarad. How many such rows it will take? Suppose that this is one such row giving you, this gives us 1 by 4 microfarad, and I will connect how many such rows? 1 is already there, I connect 2, 3, and so on and so on. The last one is, suppose this number is suppose n, 1, 2, like this. I connected this number of such combinations and to 1000 volt battery. Each branch will give me 1 by 4, and I have got n number of branches, and the total capacitance, the equivalent capacitance of the system, my requirement is 2 microfarad. So therefore this equivalent will be n times 1 by 4, and that must match with our aim 2, because this microfarad must match with 2 microfarad. That was our m. So that means the n is equal to 2 4 the 8. That means n 8 number of rows are to be connected. So this bundle of 8 such capacitors are to be connected in parallel. If I do so, my achievement, the 2 microfarad, will be achieved. So now how many capacitors I have used for this? Each row 4 capacitors, and there are 8 such rows. So total is 8 4 the 32. So total number of rows into number of capacitors in each row, that is number of rows is 8, capacitor in each row is 4, 32. So total capacitors, total number is 32. That is the answer to this question. Therefore this 32 is the right answer. Okay, thank you.